October 23, 2009. A massive explosion rocked the Caribbean Petroleum Terminal facility near San Juan, Puerto Rico. Gasoline overflowed and sprayed out from a large above-ground storage tank, forming a huge vapor cloud which ignited. The explosion damaged nearby homes and businesses. Petroleum leaked into the surrounding soil, waterways, and wetlands. Fires burned for more than 2 days, destroying 17 of the facility's 48 storage tanks.
The CSB found that current EPA and OSHA regulations are inadequate to control the hazards from facilities like Caribbean Petroleum that store large quantities of gasoline and other flammables. As a result, the company was not required to conduct a risk assessment of the danger to the nearby community from its operations, and the company did not have to implement safeguards that could have prevented the explosion.
On Wednesday, October 21, 2009, Caribbean Petroleum Corporation, or CAPECO, began a routine transfer of more than 10 million gallons of unleaded gasoline from a tanker vessel docked 2.5 miles from the facility. The only storage tank that was large enough to hold a full shipment of gasoline was already in use. As a result, CAPECO planned to distribute the gasoline among 4 smaller storage tanks. This operation would take more than 24 hours to complete. During transfer operations, one CAPECO operator was stationed at the dock, while another monitored valves controlling gasoline delivery at the terminal. At noon the next day, October 22nd, the operators diverted the gasoline into tanks 409 and 411. CAPECO used a simple mechanical device consisting of a float and automatic measuring tape to determine the liquid level inside the tanks. An electronic transmitter card sent the liquid level measurements to the control room, but the transmitter card on tank 409 was out of service, so operators were required to manually record the tank level readings once every hour. At 10 p.m., the night of the 22nd, as tank 411 reached maximum capacity, operators fully opened the valve to tank 409. At that time, an operator read the level of tank 409 from the side gauge and reported it to his supervisor. The supervisor estimated that tank 409 would be full at 1 a.m. But shortly before midnight, tank 409 started to overflow. Gasoline sprayed from the vents, forming a vapor cloud and a pool of liquid in the tank's containment dike. The CSB determined that a total of nearly 200,000 gallons of gasoline, the equivalent of 20 full tanker trucks, was released from the 6 vents on the tank. On a warm, windless night, the gasoline vapor cloud grew to cover an area of 107 acres. At midnight, the tank farm operator was ready to perform the hourly check of tank 409. But before reaching the tank, he noticed a strong odor of gasoline. He alerted the dock operator to shut off the flow of gasoline to the tank. The tank farm operator and another operator met the supervisor at the edge of the terminal. There they observed a white fog rising approximately 3 feet above the ground. The supervisor sent one operator to the security gate to stop anyone from entering the site. Then the supervisor and the tank farm operator drove to an elevated point away from the cloud to try to identify the source of the leak. Meanwhile, the pooled gasoline flowed through open valves in the containment dike toward the wastewater treatment area. There, the vapor reached electrical equipment, which ignited the cloud. A flash fire raced back toward the storage tanks. 7 seconds later, there was a massive explosion, registering 2.9 on the Richter scale. The time was 12:23, approximately 26 minutes after the overflow began. Soon, 17 of the facility's storage tanks were engulfed in flames. Fortunately, the 3 CAPECO employees escaped the tank farm, and there were no fatalities. Flames from the explosion could be seen from as far as 8 miles away. The shock wave damaged approximately 300 nearby homes and businesses. Fires continued to burn for over 2 days.
The CSB determined that CAPECO had an unreliable system for monitoring and controlling the level of gasoline inside the storage tanks. This set the stage for the incident.
The CSB found that the float and tape measuring devices used by CAPECO were prone to mechanical failure. These devices were poorly maintained and were frequently not working on multiple tanks at the same time. Also, the CSB discovered that lightning strikes and cable breakages often disabled the electronic transmitters that sent tank-level measurements to the control room. CAPECO routinely took weeks to repair problems with the level monitoring system. Instead, operators checked tank levels hourly and manually calculated the time it would take for tanks to fill, potentially introducing errors.
We found that the float and tape measuring system was the only control system CAPECO used to avoid overfilling a tank. When that system failed, the facility did not have additional layers of protection in place to prevent an accident.
Phil Myers is a nationally recognized expert on above-ground storage tanks who assisted the CSB investigation team.
The concept of layers of protection has to do with safeguards that are in place to prevent an incident. Most tank filling operations are, for the most part, governed by a single layer which has to be backed up with other layers.
The CSB notes that good engineering practice would have called for at least 2 additional layers of protection at CAPECO, an independent high-level alarm and an automatic overfill prevention system. An independent high-level alarm can detect and alert operators to the danger of an overfill, even if the primary system for measuring the tank level fails, as it did at CAPECO. An automatic overfill prevention system goes even further and can shut off or divert the flow into another tank when the tank level is critically high. The CSB investigation concluded that if both of those systems had been in place and had been properly maintained, this serious accident most likely would not have occurred. But the CSB noted that petroleum storage facilities are not regulated under the same process safety management regulations as oil refineries and chemical plants, handling the same flammable chemicals.
There are thousands of terminal facilities around the country storing gasoline and similar flammable substances, often near highly populated areas. That's one reason why these facilities should be covered under EPA's risk management program, which would require those companies to develop off-site consequence information to allow the public to learn about potential dangers.
Also, the CSB discovered that current EPA requirements under the Clean Water Act only require that petroleum storage tanks have a single layer of protection to prevent an overfill. In the United Kingdom, in 2005, a similar explosion occurred from overfilling a gasoline storage tank at the Buncefield terminal north of London. The blast caused massive damage to the surrounding community.
At Buncefield, there were numerous times prior to the incident where the automatic tank gauge, which monitors the level of the tank, was broken or the gauge was stuck. So they failed, but the problem is the management system that did not properly exist there, if it had existed, would have said, okay, that's a near miss, we need to investigate it. What are we going to do about it? How are we going to prevent this from happening in the future?
The Buncefield accident resulted in a major investigation and stricter standards for automatic overfill prevention systems in the United Kingdom, using what are called safety instrumented systems, operating at a high level of integrity. In its final report on the CAPECO explosion, the CSB recommended that EPA adopt new regulations for facilities like CAPECO to require that flammable storage tanks are equipped with automatic overfill prevention systems, and to require regular testing and inspection, as well as risk assessments.
These actions will align U.S. regulations with best practices developed in Europe following the devastating Buncefield explosion.
And the board made similar recommendations to OSHA, the American Petroleum Institute, and 2 key fire code organizations. all aimed at preventing tank overfill incidents through better tank instrumentation and controls.
Thankfully, no one was seriously injured or killed as a result of the explosion and fires at Quepeco, but the incident caused considerable damage to the nearby community and environment. Hopefully, our new recommendations will help prevent similar catastrophes in the future.
For more information on the CSB's Caribbean Petroleum Corporation investigation, please visit csb.gov.